If you like save the rappers, you can get like binoculars that say dum dum dum. But I don't really think their branding is smart. Because it's like dum dum, you know.
All right. So what we're doing today is we want to find the trig functions, the sines, the cosines of any angle, not just something on the unit circle where we get nice exact values for our coordinates, and not necessarily an angle that's in a right triangle. So we want our angles to be able to be larger than 90 degrees. So in right triangle trig, our angles had to be between 0 and 90. So we want to kind of expand our ability to work with angles. So the way that we're going to do that is pretty much exactly the way we've talked about trigonometry so far. So there are my axes, and I'm going to put an angle here, so in standard position, and we have some coordinates here, x, y, and this is my angle. And just like we've done before, we're going to project this down, turn this into a nice right triangle. That side is the x coordinate, and that side is the y coordinate. But in this case, we're not on the unit circle, so this radius, this hypotenuse of this triangle, is not 1. So I'm going to call it r. Well, from the Pythagorean theorem, r is the square root of x squared plus y squared. And now we're just going to apply SOHCAHTOA to this angle. So we're going to say that the sine of theta, opposite over hypotenuse, y over r. Cosine theta, adjacent over hypotenuse, x over r. And tangent theta, y over x. And then we have our reciprocal or our cofunctions. Cosecant theta would be r over y. Secant theta is r over x. And cotangent theta is x over y. And this angle can be any angle. It can be in any quadrant. That's how we're going to define our trig functions of that angle. We need to find the length of that hypotenuse, and if we have a coordinate there, then we can find our trig function of any angle in any quadrant. Doesn't have to be in a triangle. We don't have to have our hypotenuse equal to 1. So we can find our sines, cosines, tangents, etc. of any angle. All right. So that part makes sense. Okay, so let's see how we might apply this idea, and then we'll kind of add some layers on. So let's say that we have the point 4, -3 is on the terminal side of theta. We want to find sine theta and tangent theta. Do you know why pre-calc students don't need to go to the beach? They use sine and cosine to get tan. We have a test Friday, so we can't really do jokes. Do you know why the math students in England do go to the beach? Because that's where you find tangents.
Oh.
Tangents. That one though, I think it's arguable whether or not the gents in England are actually tan. Yeah. All right. So the nice thing about these kinds of problems, the nice thing about trigonometry in general is we can draw pictures. So let's plot this point. I usually draw little pictures. Here's the point 4, -3. So there's the angle that I'm talking about. My angle goes around like that. So that's theta. Well, what we can do, and I'll go into a little more detail about this in just a second, I'm going to project this down. And we're going to think about this little right triangle. And we're going to work with this angle in the right triangle. The only difference between what we've done before and what we're going to do now is we're going to label the sides of the triangles appropriate to which coordinate that this triangle is in. So the x part, this is 4, and I'm going to label this side -3. And our hypotenuse we always keep positive. So for that triangle, how long is the hypotenuse? 5. That's a 3, 4, 5 triangle. Well, now we're set. Sine of theta is opposite over hypotenuse, -3/5. And that's what we expect in the fourth quadrant, that our y coordinate, the sine, is negative. And tangent theta is going to be -3/4. And we're set. So as long as we keep our sides of our triangles, the x part and the y part, labeled with the sign, the plus and minus, appropriate to which quadrant we're in, we can visualize working with this little right triangle. All right. Easy enough, right? All right, the next thing I want to talk about is the sign, the plus or minus signs of trig functions. And the signs, I said plus or minus, I want to emphasize we're not talking about horoscopes. I don't believe in horoscopes because I'm a Scorpio. All right, let me draw. Let me draw a little circle here. So there's my circle, and here are our quadrants. So what we're interested in is, are the trig functions, which trig functions are positive and which ones are negative in the various quadrants. Because that gives us a bit of information about our triangle, about where our angle is. All right, so the first quadrant. X and Y are both positive. So our x coordinate's positive, our y coordinate's positive. So what trig functions are going to be positive in that quadrant? All of them. All positive. So sine, cosine, tangent, cotangent, secant, cosecant are all positive functions. In the second quadrant, which coordinate is positive there? Y is positive. So I'm going to say y is positive. So sine is going to be positive. So what's the related function to sine? Cosecant. Cosecant theta are positive. And the x-coordinate is negative, so cosine theta and secant theta, tangent theta, because we're making a ratio with the tangent of theta, we're making a ratio of a negative and a positive. Tangent theta and its cofunction, cotangent are negative. Should we color code this? So there are my positive ones. And here are my negative ones. All right, in the third quadrant, x and y are both negative. So what trig functions does that make positive? Yeah? Tangent and cotangent are positive because we have a negative over a negative. The rest of them have to be negative, right? So sine theta, cosine theta, cosecant theta, and secant theta are all negative. So let's do our color coding. What did I do? Blue for positive and red for negative. And now in the fourth quadrant, what's going to be positive in the fourth quadrant? Cosine theta, because our x-coordinate is positive, and secant theta, and negative everything else. So when we know a trig function, when we know something about whether or not a trig function is positive in a particular quadrant, that gives us information about where we're located. People come up with acronyms or mnemonics to memorize this. Mnemonics have never worked for me, so I always forget them. So I usually don't teach mnemonics because I would probably confuse you, because I would forget how it goes. What is the one that Mr. I'm not even going to say it because I'll mess it up. Well, you can come up with some kind of mnemonic. I just remember the x coordinates and the y coordinates and how that works for the positives and negatives. So let's look at an example of how we might apply this. So I'll do the example over here. So let's say that we know the cosine of theta is 3/5. Now, before we go any further, what is this? What does that 3/5 tell us about? We need one other piece. So we know since it's positive, it has to be in the first or fourth quadrant. What else does it tell us? This tells us about the sides of the right triangle. So we already know about the triangle. So cosine theta equals 3/5, and tangent theta is less than 0. So this tells us we have to be in quadrant, well, this part by itself, 1 or quadrant 4, right? But this tells us we have to be in quadrant 4. So we've narrowed it down. That narrows it down. And we want to find, what are we looking for? Find sine theta and cotangent theta. So I like to draw a little picture. Here is my triangle, and I'm visualizing working with this angle down here in quadrant 4. The angle that we're actually talking about is the one in standard position. So this is theta, the one that goes all the way around. But we can work with this angle. So this side is 3, that side is 5, this side is 4, and we're in the 4th quadrant, so I'm going to write it as -4. If we keep track of that plus and minus in our quadrants, that's what allows us to work with that angle in the triangle and not the whole angle in the standard position. All right, so we're set now. Sine theta is opposite over hypotenuse, -4/5. All right, let me pause this really quick. I'll get him set up and then we will finish this. Did we finish this now?
No. We did 96. We almost did.
You almost did? Cotangent theta is
-3.
adjacent over opposite, so we get -3/4. And we could do the rest if we needed to, but that's all we're asked to do. All right, so questions there? Okay, I want to talk really quickly about reference angles, because that's really what we've been doing, is using reference angles. A reference angle is a positive angle from the x-axis. Positive, I should say, positive acute angle. So if I draw a little coordinate system, I'll draw some reference angles here. So if we have, I'll draw some rays in here. There's one, there's one, there's one, and there's one. So these are all rays with our vertex at the origin. This is the reference angle. So in the first quadrant, the reference angle and our angle in standard position are the same. In the second quadrant, this is a reference angle. In the third quadrant, this angle is a reference angle. And in the fourth, that is our reference angle. So when we draw our little triangles the way we've been doing them in the last couple of examples, we're really thinking about using the reference angles. And reference angles are nice because the trig functions of reference angles are the same as the functions in the standard position, except for possibly a plus or a minus. So we can work with these angles, these positive acute angles from the x-axis, as long as we keep track of the positive and negative labels on the sides of our triangles, depending on which quadrant we're in, making the x's and y's positive or negative appropriately. And we get the same trig function values as we would if we thought of the entire angle from the positive x-axis. So we can think of this little angle here instead of thinking of the entire angle around from the positive x-axis. As long as we keep track of those positives and negatives on the sides of our little triangles that we draw there. And the nice thing about working with reference angles is you work with positive acute angles instead of big angles like 315 degrees or 238 degrees or 127 degrees. You can just work with a positive reference angle. And you can go out, you can figure out what the reference angles are if you're given some angle here based on where you are in relation to 180 degrees or where you are in relation to 360 degrees. So I don't want to make a big deal of reference angles other than to point out that the trig functions are the same for those angles, except for possibly a positive or a negative. And we keep track of those positives and negatives based on which quadrant we're in. All right. So we're good there. So I want to do one more example where we think about one of these problems and I want to show the example kind of like we did yesterday with two different approaches. All right, so we're going to say theta is a third quadrant angle. With cosine theta equals -1/4. Find sine theta and tangent theta. And I'm going to use two methods. Method 1, I'm going to use a triangle. And method 2, since we know some identities, we'll use identities. Well, the nice thing about this problem, using a triangle, is we can draw a picture. Here is a third quadrant angle. And I'm going to draw my little triangle there. I'm thinking about this reference angle. With cosine of theta equals -1/4. Well, that tells me that this side is -1 and this side is 4. And we can use the Pythagorean theorem to figure out that third side. So what's that going to be? Square root of 15. Remember, we're finding a leg of the triangle, not the hypotenuse, so we have to subtract. 4 squared minus 1 squared. So that's square root of 15, and we're set. Sine theta? Ah, very good. We're in the third quadrant, so this needs to be negative. So we have to label our sides appropriately to the quadrant order. So sine theta is going to be opposite over hypotenuse, negative square root of 15 over 4. And tangent theta is just going to be opposite over adjacent, square root of 15. I prefer this method just because I like to draw the little pictures. It helps, when I can visualize it, it helps me. For the second method, let's use identities. Don't we have a nice identity that gives us a relationship between sine and cosine? Sine squared theta plus cosine squared theta equals 1. So sine squared theta plus -1/4 squared equals 1. So sine squared theta equals 1 minus 1/16. And 1 is 16/16 minus 1/16, so we get sine squared theta is 15/16. So sine theta is the square root of 15 over 4. But we're in the third quadrant. So for this one, we have to think we're in the third quadrant. Sine should be negative. So I'm going to say quadrant 3. Sine theta is negative square root of 15 over 4. So that one we don't see the visual. We have to think, well, the angle is in the third quadrant. The sine of the angle should be negative. Tangent theta is sine theta over cosine theta, just like the joke. So we can say that is negative square root of 15 over 4 over negative 1/4. When I multiply by the reciprocal of negative 1/4, I just get square root of 15. So two different ways, two different approaches to get to the same place. All right, questions? Okay. Every other even there? Okay.